no matter how you look at it, because the particle will not be in two places at one time. And so what we look for is some way of writing this thing where we've got x as a function of time and y as a function of time. And usually what we do to introduce the material, and this is hopefully what you've already seen, is you just do some examples. You do something like, I don't know, let's let y equal t cubed minus 4t. And let's let x equal t squared minus t minus 2. So take a moment, based on your previous knowledge, and see if you can graph that parametric equation for the class. Anybody want to tell me what would be a good first step? Factor. Very good. Factor. You mean, can I just blindly start plugging in points? Like start at t equal minus a million and work your way up to t equal plus a million and hope you get everything? Yeah. Well, see, factoring might be a better idea, because tell me, what happens when t is equal to 0? I have an x-intercept. Because if t is 0, then y is 0. When y is 0, we call those points, I just found 3 x-intercepts. When t is 2, when t is minus 2, and when t is 0. I also found 2 y-intercepts. Y-intercepts are when x is 0. And, well, positive 2 and negative 1. So those, back in college algebra, those are the t's of interest. I wouldn't start at t equal minus a million, because all the interesting stuff is happening like between minus 2 and 2. So the t's that I would choose a t before the first one of interest. Negative 2 is the first t of interest. So I'll try negative 3, and then I'll just pick all of the convenient values of t until I get one past the last t of interest. This is hopefully what you did back in college algebra. Then you found the x's and y's, you connected the dots in order of t, and you were done. What could we possibly do in addition to that? Well, we can find out things about concavity. I can tell you using calculus where the values of t that will make this curve concave up. You might notice that they will be whatever t values give us this portion of the curve, and whatever t values give us, where would it, well, it looks like about right there, whatever gives us that portion of the curve. Those look like portions that are concave up. I should be able to find places like that. Vertical tangents. It's where the derivative is going to go to infinity, isn't it? I should be able to find places like this and like this, where I've got maximums and minimums. And that's what we're going to do in addition to what we did in college algebra, pre-calc. We're going to also find these kinds of things, inflections and maxes and mins. But let's go ahead and just graph this back with college algebra stuff, the good old days. Can you tell me what x will be when t is negative 3? You want to take negative 27 plus 12 and get minus? Oh, I said x. I'm sorry. Yeah, I was looking at that equation. You're right. So this might be easier, right? Negative 5 times negative 2. And here that would be negative 4 times negative 1. And this would be minus 3, well, times 0. I guess that's 0, and this one's 0. May as well write those. Plug in 0, you get negative 2 for x. Plug in 1, and you get negative 2 again. Plug in 3, and you get 4. A little harder to plug that stuff into the y's. But again, the factored bit might be easier. -3 times -5, that's 15 times -1. -2 times -4 is +8. Oh, that's 0. May as well write the zeros right away so I don't waste time with those again. Plug in -1, however, -1 times -3 is +3. Plug in +1 and I get 1 minus 4 is -3. Plug in 4, and well, you might notice this is an odd function, so I know I'm going to get +15. And then draw the thing in order of t. So 5, 10, 15. So it looks like we start out at +10, -15. +10, -15. And then from there we go to 4, 0. 4, 0 is somewhere, 4, 0, is that right? No, 4, 0. Damn it. I can count. 0, 3. -2, 0 looks like it's following some trajectory like this, more or less. Then what? -2, -3. So it's probably not vertical. It probably goes out beyond it a little bit. I bet calculus would verify that, wouldn't it? It'd find a vertical tangent, but college algebra only tells us that little vertical drop. Then 0, 0. And 4, 15, evidently. Right? And we draw these arrows to indicate the direction of motion.
Could you have done this using calculus?
Oh, we're going to find that same curve, but a lot more precisely using calculus. So you might remember that there are some tricks to eliminating the parameter in cases where that is possible. Now, normally it's just a matter of substitution. For example, problem 6. This is 10.1. This is junk you'll be doing over the weekend. So problem 6, x is 3t plus 1. Y is 2t plus 3. What? Wait a second. 2t plus 3. They want us to sketch the curve using the parametric equation and then eliminate the parameter and find the regular old equation and sketch that. So you already know how to sketch it from t. You would just start picking values of t. If I want to eliminate the parameter, what I'm probably going to do here is substitute for t. In other words, x minus 1 over 3 is equal to t. Y minus 3 over 2 is equal to t. So evidently, x minus 1 over 3 equals y minus 3 over 2. And so 2x minus 2 equal 3y minus 9, or 7 equal 3y minus 2x. So we're just going to get a straight line here, aren't we? Well, in some cases, there's trickery involved in eliminating the parameter. For example, problem 8, same page. Problem 8, x is sine t. Y is, was it 1 minus cosine t? I don't remember. Yeah, 1 minus cosine t. And this is where t goes from 0 to 2 pi. So that's going to be a far more difficult problem, right? When I solve for t, I'm going to get inverse sine in one case and inverse cosine in another. So maybe we ought to find a better way to eliminate the parameter there. Maybe we could use a trig identity. I mean, after all, isn't x squared equal to sine squared t? And here I get cosine t is 1 minus y. So cosine squared t is... well, I could write y minus 1 squared, because when you square it, 1 minus y and y minus 1 are the same thing. but I'll go ahead and write y minus 1 just to not offend your sensibility. And so I could now write sine squared t plus cosine squared t equals x squared plus y minus 1 squared. And what was sine squared plus cosine squared?
1.
Oh. Why, it's just a circle. You squint at me. So was that fun? That was 10.1. Hope you enjoyed it. 10.1, let's see. All right, so let me see. Shall we just do all of these problems, 1 through 52, the evens and the odds? Sorry, you didn't think that was funny at all, did you?
Yeah.
Let's see. Let's go ahead and do 1 through 21 odd. It's 10.1. Okay, and we're also going to, oh, wait, there might be a little bit more there that I want. There's some really ugly problems here. So I better not assign them.